lesson 4.8, we learn yet another way to solve quadratic equations, and this time we're going to use the quadratic formula. Along with the quadratic formula, we're going to use the discriminant to help us determine how many solutions we're going to find. And luckily, these two things are actually a part of each other. The discriminant is found within the quadratic formula, so if you know the quadratic formula, you know both. If we take a look at your note guide, the first two things that we have to define on our vocabulary is the quadratic formula, and this is a formula that helps us find solutions to any quadratic equation, and that's the good news about the quadratic formula. You can find the solution for any quadratic equation, and you're probably thinking right now, okay, why didn't we learn that one first? Well, you know, as a matter of fact, some countries, that's the only one they teach, but we've always done factoring here, and I guess that's what we'll continue to do. The discriminant, your second vocab word, for right now, let's write down the discriminant to be b squared minus 4ac, which is the part that you'll see underneath the roof of the quadratic equation. All right, so the quadratic formula, what is it? Well, the quadratic formula, you might have heard this tune before. It goes something like this.
The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Now you try.
Join in.
The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a.
And that is the quadratic formula and the way you can best remember it. So let's see what it says. It says let a, b, and c be real numbers such that a is not 0, so we have a quadratic. And like we've talked about before, the quadratic formula, or the quadratic equation in standard form is ax squared plus bx plus c. So we use the a, the b, and the c in the quadratic formula as it shows right here. Your solution will equal negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's try it. We have a quadratic equation right here, x squared plus 7x equals 0. Now, you may not have seen this on the previous slide, but the most important thing when you're going to use the quadratic formula is you get that equation in standard form, so you get the right a, b, and c. Well, in order to do that, we have to set it equal to 0. So in this case, we have to subtract a 6. Now that we've done that, we know what a is. A is 1, b is 7, c is negative 6. And I really like filling those in. Oh, right here they are. A equals 1, b equals 7, c is negative 6. I didn't look far enough down. So now if we just fill those values into the formula, we're set to go. They wrote the formula up here first, and then they filled in the numbers. So that's why we have two of them here. This is just the formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Alrighty, so let's fill in. The opposite of b, well, that's a negative 7. Then we need b squared, 7 squared, minus 4 times a. A is 1 times c. C is negative 6. Probably a good idea to use a parenthesis there so we don't forget that's a negative 6, not minus 6. And a on the bottom is 1. Now, that part itself is easy. I mean, anybody can substitute into a formula. This is the word that's going to get us in trouble, the whole simplifying. We have to make sure we do all of the steps correctly. And I know you just want to punch everything into your calculator and have it spit it out, but you got to show some work here and take some time into your steps or you're going to make mistakes. So don't try to do too much at once. If I was simplifying this, I'd first of all write that negative 7 out there, because we know that, plus or minus. Then the next thing I would do is get the two numbers under the roof. The first number, 7 squared, is 49. The second number is negative 4 times a negative 6 is plus 24. And all of that is over 2. Be really careful with that 4ac because of the minus 4a. So if one of these are negative, you're going to have a plus. If two of these are negative, you're going to end up with another negative sign in there. Now, simplifying that, well, let's see, what do we have? We have a negative 7. 49 plus 24 is 73. So we have the square root of 73, and that's all over 2. Square root of 73 does not reduce, so that would be my solution. But if we actually want some kind of number solutions, you can type this into your calculator by saying negative 7 plus the square root of 73 over 2 and negative 7 minus the square root of 73 over 2. If you do plus the square root of 73, you're going to get about 0.77. Type it into your calculator, make sure it works. Use the pause button if you have to. And if you do negative 7 minus the square root of 73 over 2, you're going to get negative 7.7. It's really important that you pause right now and make sure you type that into your calculator and it works. If it doesn't work, I can bet that you didn't put a parenthesis on your calculator around the numerator. And remember, whenever you have a fraction, you have to put a parenthesis around the numerator and around the denominator if they're more than one term. All right, here's a couple more equations, and the reason I threw these in here is they don't really talk about them much in your note guide, but the thing about these equations is they're not all ready to use the quadratic formula for yet. Remember, we have to have it in standard form. So the first thing you'd have to do if you were solving this equation is subtract your 6 and get it equal to 0. The second one is ready to solve. Here's your A, here's your B, here's your C. The third run is not ready to solve. You have x squared plus 2x. You'd have to subtract the 5, get it equal to 0. Now you have an A, a B, and a C. And notice the A is going to be negative as well. So be sure that the first thing you do is set these things equal to 0. Now, your example 2, it already has it equal to 0. But it says in your directions here that you're going to find something that only has one solution. It hasn't been too often that we've only had one solution. But in this one we will, and you're going to see why in just a second. If this is my quadratic equation, I'm going to notice that A is 2, B is negative 8, and C is 8. So if we fill in our equation, x equals opposite of B plus or minus the square root of B squared. I'm going to start just putting B squared in right away. It's going to save us some work. Minus 4 times A times C. I even like to do the A times C right away so I have less to type in if I'm figuring it out. And then 2 times A is going to be 2 times 2. So what do we have there when we simplify this? Well, let's see. Let's work carefully. We have the 8 on the outside. We have plus or minus the square root of. See, now I can do this square root here. I have 64 minus 4 times 16. Well, this happens to be 64 as well, so I actually have the square root of 0. And divide that by 2. Because that square root is 0, I don't have two things to add to 8 to get to 2 answers. I'm only going to get one answer. And that's what's going to happen anytime you have one real solution. The number under the roof is going to be 0, and therefore the only solution to this one, whoops, excuse me, the only solution to this one, this should be a 4 on the bottom here. Oh, yep, see how well this is working? The only solution to this one is 2. All right, so we can get 2 solutions, we can get 1 solution, we can even get imaginary solutions. So let's see what happens or why that would happen. This time the equation they start us with is not ready to go. We would have to subtract that 5 from both sides to get it equal, or to put it in standard form. Now my A is negative 1, B is 2, and C is negative 5. So using my quadratic formula, x equals negative B plus or minus the square root of B squared, which is 4, minus 4, A times C is a 5, all over 2A, so this is negative 1. If I simplify that, I am going to have negative 2 plus or minus the square root of. Well, under the roof I have 4 minus 20. That's a negative 16. All over negative 2. We had a whole lot of negatives going on here. We're going to have to be kind of careful with them. But let's see, there's still some simplifying I can do. In the numerator, negative 2 plus or minus, that's fine. But this square root of negative 16, okay, we worked on that with imaginary number day. We know the square root of 16 is 4, and we know when we have a square root of a negative, we have to put an I on it, and that's why we get 4I. But still on the bottom, we have negative 2. Now remember, as soon as we start dealing with an I, we have to get this thing in standard form. If I put it in standard form, that means I would take negative 2 over negative 2, that's the real number part, plus or minus. I would take the 4I over the negative 2, that's the imaginary part, and that can be written as 1 plus or minus 2I. So the two solutions, 1 plus 2I, 1 minus 2I. All right, your turn to work. There are 4 problems right here for you to solve. So solve these 2 problems and then put me on pause, and then solve the next 2 and put me on pause as well. In solving this equation, the first thing I would do is put it in standard form. So I'm going to add 16 to both sides and get it equal to 0. Now my A is 2, my B is 12, my C is 16. It doesn't hurt to write those 3 things down. It helps keep you organized. So what does X equal? X equals negative B plus or minus the square root of B squared, which is 144, minus 4 times A times C, which is 32, all over 2A. So that would be over a 4. Now I have some simplifying to do. Let's see, when I simplify that, X equals negative 4 plus or minus the square root. Okay, 144 minus 4 times 32. Well, 4 times 32 is 120, darn it, I don't have my calculator on me, 128. And when you simplify that, 144 minus 128 is 16 all over 4. So I have negative 12 divided by 4 plus or minus 4 over 4. So what do I have? Let's see, negative 3 plus or minus 1. So negative 3 plus 1 is negative 2. And negative 3 minus 1 is negative 4. There's my 2 solutions. Number 2, I have 4x squared. I have to get this in standard form, so I'm going to subtract a 7 to make this negative 20x, and then add a 25 to get it equal to 0. So my A is 4, my B is negative 20, my C is 25. So let's see, x equals the opposite of b plus or minus the square root of b squared, which would be 400, minus 4 times AC is 100, all over 2a. So notice what we have under the roof. We have 400 minus 400, so we have a 0. So I know right away I'm only going to get one answer. That one answer is 20 over 8. If I reduce that down, 4 goes into 25 times, 4 goes into 8 2 times, and there is my only solution. Okay, work on the next 2. Pause me while you do. Both of these will have i's in their solution. So the first one, A is 3, B is negative 6, C is 6. X equals the opposite of b plus or minus the square root of b squared minus 4 times AC. Let's see, 6 times 3 is 18, all over 2a, which is 6. All right, well, under the roof there, I can see I'm going to have a negative number because I have 4 times 18, which is 72. So 36 minus 72 is going to give me the square root of negative 36. So I have 6 plus or minus the square root of negative 36 all over 6 for my x answer. Well, I can see because that's a negative 36, I'm going to have an I. So what do I have so far? I have 6 plus or minus 6i over 6 over 6. So if I put that in standard form, I'm going to have 1 plus or minus I for my values of x. 2 answers, but both have an I in it because I got a negative under here. Okay, number 4, let's see. A is 1, B is negative 3, C is 3. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so x equals 3 plus or minus, under the roof I have 9 minus 12. So that's going to be the square root of negative 3 all over 2. Well, the square root of negative 3 is going to give me an I, so let's see what I have. I have 3 over 2 plus or minus I square roots of 3 over 2. And since I don't have any square roots in the denominator, I'm done. That's my answer in standard form. All right, now you notice that sometimes we get 2 answers, sometimes we get 1 answer, sometimes we got imaginary answers. And what determines that is something that we call the discriminant. This is out of the book. I just like the way it's color-coded. Here is your quadratic formula, and notice the red part under the roof is what we call the discriminant. And here's what happened. Either that discriminant was a positive number, or the discriminant equaled 0, the thing under the roof was 0, or the thing under the roof was negative. And all 3 of those situations may happen, and they all give us a different result. First of all, if it's positive, it's kind of like your normal old parabola. You're going to get 2 real solutions. If it's 0, you're only going to get 1 solution because there's only one thing, or there's nothing to subtract from your b because it ends up to be a 0. But if it's negative, you're going to get imaginary solutions, and those imaginary solutions come in pairs as well. Now, that's what you're going to see on your solutions, but here's really what I think is the important and I think the interesting part, and that is, what do these graphs actually look like? Well, here's the reason you get 2 solutions. We talked about how a solution is the same as the 0, is the same as the intercept, is the same as, which one am I forgetting? The factor. So if we take a look, if we have 2 solutions, we must have had 2 intercepts here. So you get the normal looking parabola cutting through the x-axis twice. But see, sometimes that doesn't happen. Sometimes that parabola sits right on the x-axis, so you're only going to get 1 solution because there's only 1 place that is touching the x-axis. And then not all parabolas go through the x-axis. Here's an example of one that doesn't. So those solutions are imaginary because there isn't real number solutions on the x-axis. Another way that could happen is if your parabola is going upside down and it's in the bottom half of your coordinate plane. You're also going to get imaginary solutions. So that's what the picture will look like on your graph that would help you determine what kind of solutions and how many you're going to get. And that's what the discriminant does for you. So if you take a look at your box on your note guide, let's see. Oh, I thought I had one filled in, but I don't. Okay, let's fill this in. When your discriminant is positive, the equation has 2 real solutions. Positive gives us 2 real solutions. So the graph has to have 2 x-intercepts then. When that discriminant is 0, the equation has 1, but it's still a real solution. And the graph has only 1 x-intercept. It sits right on the graph. But then here's the other case. If that discriminant is negative, you still get 2 solutions, but now they're imaginary. 2 imaginary solutions. And the graph isn't going to show any x-intercepts or zeros because it doesn't cross the graph. So we have to fill that in as a no. All right, so we're just going to look at the discriminant and determine how many solutions we're going to have on this next one. We're not even going to solve. We're just going to say how many there is. All right, if we do this first one, the discriminant is b squared, which is 36, minus 4 times ac, which is 5 times 1. So 36 minus 20 is 16. All right, so then how many solutions do we have? We're going to have 2 real solutions. All right. If you want to work that one out and get some more practice, you're going to get a -5 and a -1. Second one, let's see. If we do b squared, we again get 36. Minus 4 times AC is 9 times 1. Well, 36 minus 36, you get a discriminant of 0. And when you have a discriminant of 0, you only get one real solution. And if you want to work those out, you will find out that that one solution is negative 3. And then finally on letter C, again we have a 36. This time we have minus 4 times 13 times 1. Well, 4 times 13 is 52, so our discriminant is negative 16. So I know already my only answers I'm going to get are imaginary. I'm going to get two imaginary, meaning they're going to have I in them. And if you work that one out, you're going to find out those two imaginary values are negative 3 plus or minus 2I. All right, you have 4 more to try. I know you've done a lot of solving already, so I am totally fine with if you just find the discriminant, which is a one-number value. When you find a discriminant, you give me a number, and then tell me how many solutions you have. So put me on pause and do these 4. All right, b squared is going to be 64 minus 4 times AC, which is 17. So 64 minus 4 times 17, and we get negative 4. So the discriminant is negative 4. The solutions are 2 imaginary. The discriminant is negative 4. It's a single number answer, and that's what I'm going to ask for on the test. So don't tell me 64 minus 4 times 17 and all this other stuff. The discriminant is negative 4. Okay, the next one, b squared is 16 minus 4 times 3 times 1. So 16 minus 12, the discriminant is 4. So I'm going to get 2 real solutions. In this one, b squared is 4 minus 4 times a times c is going to give me a positive 1. 4 minus 4, the discriminant equals 0. I am going to get 1 real solution. And then finally this one, I have 36 minus 4 times a times c is 4. 36 minus 16 is 20. My discriminant is 20. Again, I'm going to get 2 real solutions. All right, that is the quadratic formula. You've seen it briefly in the past, but now we're really going to use it as one of our ways to solve equations, quadratic equations. And your homework, come up and get your worksheet 4-8 and get started on the quadratic formula. That's it for today.